Hi there, this is Mr. Cardoso, and we are on lesson 7 of our Intro to Objects. And really this is a continuation from our last lesson where we were taking up question number 2 from section 6.2. We did plus equals in the last video lesson, so if you didn't get a chance to watch that, go back and watch that video. And here was that method here. And this one we want to do plus. And so there's a difference between plus and plus equals is that, just where you store the result. So for example, in plus, I might say, int x equals 2 and int y equals 3, and then I can say int answer equals x plus y. Right? So now in this method, right now, this is what we're doing. We're essentially making a third variable. So the values of 2 and 3 haven't changed, or x and y, I should say, haven't changed from 2 and 3. In the plus equals method that we did above, this was really like doing this. Int x equals 2, int y equals 3, and then we said x plus equals y. Well, x now will have the 5 in it. 3 plus 2 is 5. And now x no longer has the 2. The 2 would have been gone and replaced with 5 because we put the answer into x. And so we no longer kept the 2. Whereas here, we still have kept the 2 and the 3 in x and y, respectively. And answer is the one that has the 5 in it, so we created an additional variable. So depending on what you want to do you want to keep the values of x and y, or do you not care about that value of x and you can replace it? So depending on what you want to do, you'll use one of these two scenarios. In the same way, we have the plus equals method, which we created last time, and then the plus method, which we're going to create this time. And so the user can choose, or the other programmer can choose which method they want to use depending on what they're trying to do, if they want to keep that value or not. So over here, just to recap, I wrote some comments up here, which we should be doing in all of our methods in this format. So this method takes another fraction, this is for the plus equals, and adds it to the implicit fraction, or this fraction, right? And so that's why this one is void. It's void because we will be modifying the implicit fraction. So just like here, we modify the x, here we're modifying the implicit fraction. So when we call it, here's where we call it, we go f1 dot plus equals f2, right? So we are going to modify the fraction, whichever fraction is before the dot. So if I put f2 here, that's the one that's going to be changing. And notice that's on the left-hand side of these equal signs here. So that means those values are actually changing. And it's void. We don't have to return that. So it's actually changing those values. So in lesson 5, again, we talked about how this is important because this is passed by reference, right? So it's not copying the fraction in there. It is actually changing f1. So f1 and this, when in this function call right here, in this method call, f1 and this point to the same fraction, right? And f2 and other point to the same fraction. So if I changed other in here, that would change f2. But I'm not changing other because this is the only one on the left-hand side of the equal sign. So hopefully that makes sense. Now we're going to do one version, the part B, which looks exactly like, excuse me, which looks very similar like to the times method. So I can go public fraction plus fraction other. I know they called it fraction f over here, but we can still call it other. You can call it f if you want to. So it's the plus method is going to do exactly what plus equals does. So in fact, I'm going to copy and paste this here. The key difference is we are not going to modify any of the two fractions. So like we talked about down here, we're going to put the answer in another variable. So for example, I can go fraction, let's say answer, maybe a sum would be a better variable name because we're finding the sum of two fractions, but I'm going to call it answer just to relate it to the example that we did when we were doing those the math examples that we were talking about, like right here. We created a third variable called answer. So we're going to create a new fraction called answer. And so that's the one that I'm going to populate. So answer.new gets this done. So that formula and this formula are exactly the same. And answer.den, those are the same here. And the other key difference is we have to now, the return type is fraction. So we're going to return answer. Okay. So now in this one, and I hope you've realized in all of these lessons, when I use this dark blue color, I'm kind of working within the fraction calculator. And when I use the green color, I'm referring to the fraction class. So let's go down here, and I'm going to call that method now. So I'm going to go fraction, and now I have to create a place to store, because this method is actually like the times method that we did up here. It's returning something, so I need to put something on the left-hand side. So let's call this one sum. So fraction sum equals f1 dot plus f2. Okay, now I'm calling this other method f1 dot plus f2. Now notice again in this one, I didn't have anything on the left-hand side because it was void. It was modifying f1. Here, it's not modifying any of f1 or f2, and it's placing the result in sum. Now the interesting thing here is, because this one is modifying f1, we're actually not going to be adding 1 over 2 plus 3 over 4. 3 over 4 didn't get modified in this line number 25. The f2 didn't get modified, but f1 did. In fact, f1 at this point will have 10 over 8 in it. Right? At this point it will have 10 over 8 in it. So here, if we want to add the original 1 over 2 plus 3 over 4, let's just comment this line out. Otherwise it would add, if we don't comment out line 25, this would be 10 over 8 plus 3 over 4. Right? So if we want to add the original 1 over 2 plus 3 over 4, let's comment out that line. So that's one of the effects of this, is it changes that value. So you have to be careful when you do change those values. Make sure that the secondary programmer knows that those values are being changed. Okay, so because they made a fraction f1 with 1 over 2 in it, and then they try to use that 1 over 2 later on, and they realize, oh, it's not 1 over 2 anymore. They get wrong answers. So that must be well communicated in comments and documentation that that's going to modify this, right? So now we've got f2, which is still 3 over 4. Okay, and since I've commented out this line, it's back, f1 is back at 1 over 2. Now, when I call this, f1 is before the dot. So when I go back over here, f1 is the implicit fraction, and therefore becomes this. So this, in the fraction class, is pointing to f1, and other is pointing to f2. And again, in the fraction class, there's no idea of f1 and f2, so this and other will point to those, and that's what those things are passed into these handles. So now we add them according to this, what we've done up here, the math that we've done here. We add them and we return, we've created answer. Sorry, I forgot this first line. So we create this answer over here, answer, and that points to nothing. It will be blank, and then we populate it. So we do, and we get 10 over 8 if these are the values for this and other in this example. And so now it returns answer. And where does it return answer? It returns answer back here. So this gets replaced with answer. And on the left-hand side, that's sum. Now remember, I said that sum, we didn't create a new fraction for sum. sum was pointing at null, because we didn't use the new keyword like we did up here and here. So sum actually doesn't have a fraction, but that's okay. The new keyword was used here, right, in answer. And so one was created, so we don't have to create another one, because that would just be wasteful. So now sum points over here at answer in the fraction calculator class. And so it has answer in it. So now we can do something like system.out.println. Instead of this, we can say the sum of f1 and f2. Oops, I forgot a plus sign in there. Is, and we can say sum. So we compile that and hit the run button. So now we get the sum of 1 over 2 and 3 over 4 is 10 over 8. So 1 over 2 wasn't modified, and 3 over 4 is original, and then the sum has 10 over 8 in it because we added it and placed it in sum. Hope that makes sense to you. We didn't. It would be nice if we reduced it, but we'll do that in our next lesson. Now, if we did this way, first of all, we wouldn't even have a sum, right? If we use the plus equals method. So we'd have to say the sum of f1 and f2 is, well, where's the answer? In this case, it puts the answer back into f1. So we'd have to do that. Do you see the problem here? Hopefully you do. Compile that and run it. If we do it that way, well, yeah, f1 has changed. It's no longer 1 over 2, and this is now an incorrect statement. Because 10 over 8 plus 3 over 4 is not 10 over 8. The reason why it's doing this is because f1 got changed. So when you use f1 here and f1 here, well, it got changed in this line to the answer 10 over 8. And we no longer preserved our f1. So in this situation, the user probably wants to use this version of it and use sum here. And in this case, the user would, the secondary programmer, as I'm doing here in Fraction Calculator, I'm the secondary programmer, would probably want to use this version of plus instead of the plus equals. But there are some situations where you want to do plus equals. If you don't care about f1, if you want to update the value, just like you do here, you don't, on this side here, you don't care about the x value, you want to update it. There are scenarios for that too. Okay, I hope that makes sense, the difference between the plus and the plus equals and changing. The important thing here is the difference between these two methods right here, right? The plus and the plus equals. Here again, we're modifying one of the operands, either this fraction or the other fraction. So you have to be careful and communicate that well to the secondary programmer in these comments. And here we're not modifying either one of the two operands, this or the other, or f1 or f2, and we're creating a new one and putting the answer in there. And that's a very, very important difference. Hope that makes sense, and we'll tackle the reduce method in the next video lesson. Thanks.